3,745 miles from Minnesota to Florida and back. But why is it still so cold here? Anyway, you've seen enough of me, so most of this will be voiceover as we get into the stats of the trip. We'll also make a stop-by-stop comparison of the drive home from this trip in our 2021 Tesla Model Y with our 2020 Frunkful of Diapers trip returning from Orlando in the 2015 Tesla Model S 85D we owned previously. That's a lot of dates and info, but it'll all make sense. Let's cover the big questions first. How long does it take to charge? Our average charging stop was 32 minutes, but that includes about a 44-minute plus hangout with Jim, the Iowa Tesla guy, and an hour and 38 minutes hanging out with EV Dave, plus traveling with a child in diapers. In stops where the car gave us an estimated charge time to continue, we averaged 7 minutes longer than suggested. So I'd estimate traveling alone with no extra hangout time, the average stop could have been 20 to 25 minutes or less easily, similar to what we found in our mountain adventure last summer. Next, the cost of charging, and this seems to have gone up recently, but the total trip was only $338.08, compared to a gas car getting 30 miles a gallon, which would come to $436.92 if the average gas price was $3.50. This, of course, was helped by hosted destination charging we got overnight at hotels, which had us starting full every morning and saving us 5 supercharger stops, all for free. The mileage we traveled per day on the way down was 530 miles the first day, 535 the second day, 530 the third day, and 336 miles on the final day. Coming home, our day 1 mileage was 526, day 2 was 625, big day there, and day 3 was 549. Again, bringing us to the total of 3,745 miles when you include all the driving around in Florida itself. And we averaged 340 watt-hours per mile over the entire trip. Now we get into the real fun stuff of the spreadsheet. And I'm intentionally not moving this much so you can get a really good look at the stats you care about, because I know not everyone cares about the same things. You can see how I broke items down here across the top, starting with the day, what number stop we were on for that day, location, travel distance from the last stop, travel time from the last stop, that segment's trip average watt-hour per mile, our arrival state of charge, the charge we used on that trip, departure state of charge, total travel distance for the entire road trip, total travel time for the entire road trip, and then taking the readings of the total trip average watt-hour per mile as we went along. So you can see as we went south, that started getting better. When the car displayed it, or I remembered to note it, I took down our charging time suggested at each stop. You can see I was a little sporadic there, but I was a little more meticulous with the total stop time actual, and that includes the charging, if we were late while shopping or hanging out, all that kind of stuff, to show really what the timing was for our actual time at each place. And again, like I said, our average came out to be about 7 minutes more than what was suggested. So we could have left almost every stop earlier than we did, we just had life get in the way. I didn't include the time stop to destination chargers, so you can see there's a couple NAs for not applicable in this column, since we were there overnight. Next column, you can see charging cost, and that is actual from Tesla, what they billed me. The temperatures, once we got out of Minnesota and Iowa, were pretty good, and you can see them in that column there. And then our trip energy used, the first column here is kilowatt hours used per trip. And then the total energy used is that cumulative as we go through the trip, adding each segment together. And as we get to Cocoa Beach and the days down there, like I said in the video series, I didn't do a great job of keeping stats those days, but really that's everybody's destination is going to be different, and the road trip stuff is more important. And you can see we averaged about 4 or 5 charging stops per day. So it broke the day up nicely, especially when traveling with a child. Our average arrival state of charge was 28%, so again, another place where we left some charging time on the table. We did not need to get to some of those chargers with that much. It's good to have a safety buffer, but that's pretty excessive. I will say it is comforting in the northern climates when you have really cold temperatures to know you have enough buffer, but we probably should have sped up toward the end and burned some of that juice and made up time. Although most of the time I was driving with the speed of traffic and wouldn't have wanted to go too much faster than we were. Our average departure state of charge was 85%, and again, we could have had that go lower as well. But if you're going to be at the chargers anyway doing personal stuff, you may as well stay plugged in and just make that next charge a little shorter. So we tried to do our best with that. And as we scroll down to the second part of the trip, you can see obviously the same header columns, but at the bottom I have some averages and totals and a little bit of information on the trip home, which we'll get into in a little bit here. So our average travel distance between stops was about 111 miles, so about every hour and 40 minutes, depending on where we were in the country, which was a pretty good break time for Joan. Here you can see that arrival state of charge was 28%, our charged used average was 54%, and our departure state of charge average, as I said before, is 85%. Now, interestingly, on that 54% in the middle there, the charge we used driving at each stop, obviously we could have used 70%, 80%, 90%, and gone more miles per each charge. But you also have to stop where the chargers are, and so running your battery all the way down in a place where there's no chargers doesn't make sense. So until charging is a little more ubiquitous, you're going to be stopping at most chargers along the path, although we did skip a few, and we'll see that when we do the comparison. Our total travel time for the whole trip was 27 hours and 29 minutes. Add 13 hours of charging onto that, and you get about 40 hours of being in or around the car on the entire trip. We talked about cost a little bit earlier at $338.08. And finally, the total energy used to do the whole trip was 1,272 kilowatt hours, or 1.2 megawatt hours. So good and juicy there. If you need more time with these pages, feel free to pause and look around. But for now, we're going to move on to comparing this trip home from Cocoa Beach to Minnesota, almost identical to the trip we did in 2020, coming home from the Frunkful of Diapers trip in our 2015 Model S. So we'll take a look at some of the stats and how they compare, how the stop cadence compares, and I think it'll give you an idea of how the technology has changed between vehicles and charging infrastructure in just 2 years. This trip will be represented in red, and the 2020 trip will be represented in blue. And though we both started from different places, we essentially started from Orlando and made our first stop in Ocala, Florida. You can see the difference in how long it took us to get there from a mileage perspective, but the time at the charger for each stop, our arrival state of charge and departure state of charge, rough estimated cost, our 2015 Model S got free supercharging, so this is a very rough estimate based on cheaper costs a couple years ago and not being able to charge as fast in that vehicle. So take these lower numbers with a grain of salt, but I threw them in there as a rough approximation of what charging costs were around that time. But if you have data suggesting this is completely wrong, I wouldn't be terribly surprised. But I wanted to give you some sort of sense of what the charging costs would have been on that trip. And at the bottom, we'll take a look at the full trip miles as we go and how much time we spent at the chargers combined. So that's a number that's going to get really interesting as we go. One other caveat to the 2020 trip is it happened a couple weeks earlier in the year. The temperatures the whole way up were considerably colder. I think we were in the 30s or 40s by the time we were in Georgia. And we had pretty mild weather all the way to Minnesota before it got that cold. So again, we'll need to take that watt hour per mile per trip with a grain of salt, accounting for colder temperatures. Before I started putting these numbers together, it never occurred to me that our 85D Tesla Model S had about the same capacity as the 87 kilowatt hour pack in our Model Y. But you'll get a sense of the efficiency difference and the speed of charging when we look at here, even in our first stop. We were at the charger 12 minutes longer in 2020 and only went from 31% to 82%, where in this trip we went 15% to 92% in that shorter time. The cost was higher, but it got us on the road faster. As each car got to the second stop, you can see the Model S only traveled 81 miles, where the Model Y went 142. Now, part of this is due to charging infrastructure, that where the Valdosta stop in Georgia may not have been online in 2020, And so the Model S had to stop because that was the next charger and it needed all of the chargers, where the Model Y could skip a charger and use more of that battery pack. Here again, a little less time at the charger, 27 minutes to 31, and we got considerably more range added. So this must be also a V3 supercharger, which definitely means it was not around in 2020. You can also see our watt-hour per mile on this trip is much more efficient in the Model Y. So already by stop 2, we've gone considerably more miles and charged in less time in both of those spots. Stop 3 for each vehicle. We stopped in Tifton, Georgia in the Model S and went up to Cordell in the Model Y. Now these lengths between chargers are pretty similar, 94 miles in the S going a little further and 87 in the Model Y. But you can see by the time at the charger that the Model Y was just doing a pit stop to get us to our night stop, and the Model S was loading up again to go more distance. And by stop 4 on this current trip, we were already at our night stop. Now, we probably should have pushed on further. We talked about that earlier in the episodes. How had I had my timing better, we would have gone past Atlanta for sure on that first day. But that was our night stop, so we're not going to count any time being at the charger since we were using destination charging overnight. We'll extend that same courtesy when we do the night stop for the Model S. But here you can see that since both of these vehicles' last stops, we did about the same distance, pretty similar, 109 miles to 116, but took an hour and 12 minutes at this charger for the Model S, going from 14% to 90%. Like I said, that watt-hour per mile is still a little higher, partially due to the vehicle, partially due to the cold. But 4 stops in 2020, we'd only gone 381 miles, where we'd already done 505 in 2022, and charged significantly less. As we advance here on the map, you'll see a little red box appear next to the McDonough, Georgia stop, and that's to indicate that was our overnight stop. You'll see that again in blue for the overnight stop there, and our other overnight stop in St. Louis. Stop 5 was Ackworth, Georgia in 2020, 109 miles past the last stop. Stayed at the charger for an hour and 12 minutes, went from 33% to 93%. But when we look at the V3 charging in 2022 at Adairsville, Georgia, these stops aren't very far away, but we'd gone 90 miles since our overnight stop, and we're only there 24 minutes to get from 32% to 84%. The magic of preconditioning and version 3 supercharging on a vehicle that can take it is a pretty significant difference. But I also want to acknowledge that these time at chargers did include any personal needing to change a diaper, more time at a restroom, shopping, eating, that kind of thing. So this wasn't all necessarily charging, but it's fairly comparable between the two. Stop 6 for both vehicles was Manchester, Tennessee, and this is where in 2020 we did our overnight with confused time zones and only got a couple hours of sleep. Unfortunately, it wasn't super restful and we slept in the car, but I'm not going to include this time at the charger because that was our night stop. So to be fair, I'm going to eliminate that. We did go from 9% to 83%. Well, Joan slept and I half slept, and then we moved the car and slept for another couple hours behind the Dunkin' Donuts. On the 2022 trip, this was probably our longest stop on the way home at 47 minutes, and there was some debate at the time about why it was having us charge that long there. Could we have stopped at one of the chargers at Nashville? But there was so much traffic and congestion in Nashville, I think it made the wiser choice, even though the charger was 125 kilowatt, I believe, in Manchester, to have us stay there a little longer and just get through Nashville and that rat's nest of traffic as fast as we could. So we went from 19% to 97%, and knowing when we got to our next stop we didn't need that much, we could have left here earlier and made that charge stop shorter, but we were playing it safe and not in any big rush. Some of the extra miles we put on were stopping in Chattanooga and going up and down the mountain, so we used up a little extra coming up to this stop. But as we're paired up here at stop 6, and we've now had overnight canceled out on both trips, you can see that we've already saved 2 hours of charging just by using the faster, newer infrastructure and the faster charging vehicle. Some of that, of course, is due a little bit to temperature, but not that much. And that gap is going to continue to widen as we go. And stop 7 is where we really start to see the range really take off. In 2020, we had to stop at Nashville. We didn't need a ton of charge there, but we were there for 41 minutes, where in 2022, we skipped right through Nashville, went 171 miles all the way up to Cuttawa, Kentucky. And there we were able to charge from 18% to 83% in only 30 minutes. Stop 8 took the 2020 trip up to Cuttawa, and in 2022 we were up to Mount Vernon, Illinois. So 110 miles in the Model S, but we were at the charger for 54 minutes, going from 18 to 75%. Where in Mount Vernon we had gone 131 miles, but we're only at the charger for 19 minutes to get from 19% to 67%. So pretty efficient in the Model Y. And if we quick think back to our Cuttawa stop in the Model Y, we went there from 18% to 83%, I believe, in 30 minutes instead of the Model S doing that in 54 minutes, going from 18 to 75. Now, part of that is the preconditioning factor, and the Model S did not have navigation in it. It had the map, but you couldn't navigate to certain things. So it didn't know when it was arriving at a charger, and so couldn't precondition. We just showed up as cold or warm as the battery was and got whatever the charger decided to give us. So another little handicap with that particular Model S from 2015. Stop 9 brought the Model S in 2020 up to Mount Vernon, Illinois, charging there for 43 minutes. Meanwhile, in 2022, the Model Y has stopped in St. Louis for our second overnight stop. Now, this is another big difference we talked a little bit about during the episodes, but I only stopped for one short overnight trying to beat a snowstorm in 2020. That was not advisable, but that also means that we're counting that charging time as keeping us off the road. Whereas in 2022, we're using destination charging, getting that extra free charge, and not adding any time to our trip. So that helps from the cost perspective and the time perspective. Although we had added more days to the trip, it was much safer, much more comfortable, probably smarter. Stop 10 is where our paths really started to divide. And again, this goes back to infrastructure. With more infrastructure for charging in eastern Iowa now in 2022 compared to 2020, we could do a straighter shot up to Minnesota through eastern Iowa. Where in 2020 with the Model S, we had to make more stops up through Illinois toward Chicago, then back and arcing across southern Wisconsin. And here again, you can see the Model S in colder weather and with fewer infrastructure possibilities along the way, it needing to stop at every charger and having to stop 67 miles in for 52 minutes to get from 25 to 82%, where in 2022, the Model Y went 104 miles and in 36 minutes picked up 30% to 91%. So again, just much more efficient. And you can see that combined charge time is really starting to diverge, even though the miles aren't that different. Stop 11 in 2020 was in Normal, Illinois. That ended up taking a lot of time, an hour and 3 minutes. I believe the chargers were in a parking ramp to like a bus depot or something. A lousy stop way off the highway. Ate up a lot of time, not only charging there, but getting to and from the interstate. So a frustrating stop on the long day. Meanwhile, in 2022 with the Model Y, we stopped in Coralville, Iowa for 33 minutes, went from 17% to 86%, and we're on our way. Again, that temperature was helping us out in 2022, and you can see that in the difference in watt hour per mile on the trip from 332 this trip compared to 413 in 2020. Stop 12 was a longer stop in 2020, partially because that was our dinner stop, and we had to walk in and out of the mall. Joan was a little squirrely, but in an hour and 9 minutes, we went from 8% to 87%. And charging longer here helped us avoid one stop in Wisconsin, so that was pretty good. Although a long stop, we did make the most of it. In 2022, up here, we're already to Waterloo, Iowa, having gone only 83 miles, but it set us up for the run to Albert Lea and then home. So just a quick stop here of 23 minutes, getting from 43% to 87%, and back on our way. Stop 13 and 20, we were racing to stay ahead of that snowstorm, and although we avoided one stop in Wisconsin, we did have to stop at Mauston for 52 minutes to get from 8% to 75%. Well, in 2022, we're on the home stretch, just a few miles from home, and we'd gone 131 miles from Waterloo, kind of cross-country, trekking over to Interstate 35. And just a quick pop in to Albert Lea for 19 minutes, going from 16% to 59%, and that warm weather helping keeping our watt-hour per mile down. Stop 14, and in 2022, we're already home after going 82 miles, and our total charge time combined for the trip home was only 5 hours and 18 minutes. Meanwhile, in 2020, we were back in Eau Claire, Wisconsin, charging for another 45 minutes, going from 14 to 71%, that watt-hour per mile creeping up to 403 in the cold, and still having one more leg before home. And that final leg in 2020 brought us home. After 108 miles from Eau Claire, we arrived home with 5% state of charge after going 1,620 miles from Orlando to home, and we needed to charge for 11 hours and 35 minutes. Compare that to 2020, 1,679 miles, only stopping for 5 hours and 18 minutes that affected our trip. So well under half the time that it took just 2 years ago, with a combination of better technology, more efficiency, and more infrastructure. And that's only going to get better as all of those elements continue to improve as more and more EVs are on the road. Speaking of preconditioning, the best practice is obviously precondition while plugged in before you start your days. On the road, navigate to your route and let the car do what it wants. In most cases, you'll be fine, and it'll keep the battery healthy long term and help you charge quickly. In very cold temps, if you're worried about making it to your next stop, or in heavy winds, skip preconditioning by navigating to the town first. Then if you've got enough range, re-navigate to the superchargers when you're closer, 30 minutes or 10 minutes before you arrive. You'll give the battery a heads up, but still be able to feel confident with your arrival. And speaking of confidence, the Tesla Nav in the car and supercharger network make it so easy and easier all the time that there really isn't a need for anything else during the trip. I did plan the route in advance with a better route planner and find the destination chargers with PlugShare. But during the trip, I didn't use any of the apps I'd recently downloaded, and their notifications were more annoying than anything. I did use the PlugShare app once or twice near Cocoa Beach to see what was around, but we could have been fine without it. Other quick notes here, I did use FSD Beta most of the time, and it did fairly well. My disengagements or corrections were mostly out of courtesy to other drivers around me, in intersections or speeding up when it was too timid. And for me, it seemed to work equally well in the cities or in the boondocks. Still needs some work, but overall, it's very helpful. Especially compared to our 2020 trip, there were a ton more EVs on the road, which was great to see. A few Mustang Mach-E's, a Polestar 2, Leafs, Bolts, PHEVs, and of course other Teslas. Awesome to see the transition happening. Like the end of most other trips, I wish we would have taken the days a little slower and had more side adventures like the Great Smoky Mountain National Park and Chattanooga's Lookout Mountain. They break up the days and give you insights into the world that you wouldn't have had, but they do take up time. And finally, speaking of time, thank you for spending your time watching our adventures. For future trips, let me know what you'd like to see, what I should leave out, stats I missed, or if you have any questions, add those down below. Thanks to Jim, Dave, Tricia, Michael, Ellen, and of course Joni, my road trip companion. Wishing you all a great summer of road trips. Thanks for watching, and have a great day.